What's up, sports fans? Today we're talking about the power of zero and negative powers or negative exponents. Reminders, this is from the last lesson. I'm not going to teach it right now. If this doesn't feel familiar to you, please check out that last lesson. Otherwise, I'm about to lose you. So if you have x to the a power times x to the b power, same base. The result here is x to the a plus b power in blue. In red, if you have x to the a power divided by x to the b power, again, that x is the same x in both of these pieces here. Then you can just do x to the a minus b power. Check that last lesson if that's new to you, please, please, please. Okay, example, x to the third power divided by x to the third power. Let's first use the division rule of exponents here in red, and then we'll talk about some of the things you might be noticing right now. So this just says, well, I'm noticing they both have x as their base, it's the same, and so I take the exponent on the top, so it'd be x to the third power minus this exponent here. Well, that ends up being x to the 0th power. Yikes, what do we do with that? That feels weird, that feels uncomfortable. How do you raise a number to the 0th power? Like all day long, I can do x squared, x cubed, whatever. That's just multiplying it by itself however many times. Well, here I multiply it by itself 0 times, maybe. What do we do with this? Well, it turns out it's kind of funky, but I want to show you why it's funky versus you just memorizing a rule. If we dive in a little bit deeper here, notice that, x cubed, this is me separating, this is not a fraction, this is just me doing the work a different way. Remember, math is like art, different styles. So we have, this is x times x times x over x times x times x. We can break this down, x times x, or sorry, x over x. Well, anything divided by itself, isn't that just 1? And then we have x over x again, which is just 1, x over x again, which is just 1. Weird, so the 1 times 1 times 1 is just 1. And really, we could have jumped to this point from the get-go, x cubed over x cubed, even though we don't know what x is, we know that x is x, and so whatever the stuff on the top, whatever this value is, must be the same as the stuff on the bottom. Anything divided by itself is just 1. So, what this tells us, interestingly enough, is that anything raised to the 0th power is just 1. And it's because of this division rule of exponents. If you have the same base and you subtract the top exponent from the bottom and the bottom exponent from the top, x to the 3 minus 3 is 0. And that's only going to happen. You're only going to get a 0 exponent when you have the exact same thing on top that you do on the bottom. So it ends up canceling, as it were, and it just turns into 1. Let's look at it with real concrete values here. 2 to the third power over 2 to the third power. Well, that's 2 to the 3 minus 3 power, which is 2 to the 0th. And we just talked about how this is going to be 1, but let's convince ourselves. 2 times 2 times 2, that's 2 to the third power. 2 times 2 is 4, times 2 again is 8. So again, different style, same problem. 8 over 8, well, that of course is just 1. So what we can say for sure with a 0 power is that x, where x is anything, it can be 1, it can be 2, it can be a million, it could be a bazillion pi to the 100th power, whatever it is, if you have some value for x and that whole thing is raised to the 0th power, the result is just 1. I encourage you to keep that in mind. Please don't memorize it for the sake of memorizing it. Please keep in mind what's actually happening here. We're leaning on a rule that we learned previously, but because of this rule, it has a really interesting consequence that can help you simplify some problems pretty quickly. Okay, this next one. Let's talk about a different situation. Separate this out again. Here we have x to the third power divided by x to the fourth power. Well, again, using that division rule of exponents, that's just going to be x to the 3 minus 4th power. Well, 3 minus 4 is negative 1, so that's x to the negative 1st power. Weird. Negative exponent, what does that mean? What do we do with it? Let's again approach this from a different style. This could just be x times x times x over x times itself 4 times. And just like what we've talked about before, a lot of this stuff cancels out. X over x is just 1. So we end up having 1 times 1 times 1. Well, then if you just multiply the top by 1, it doesn't change the value. We end up with 1 over x. Or if we want to be a little bit over the top, we can say 1 over x to the first power. Interesting. let's put that on pause for a quick minute. Let's look at this other example and kind of see if we can find some patterns here. I'm going to change colors real quick just to differentiate what's going on here. So here I have 2 to the 5th power. I wrote this wrong. I'm going to rewrite this example. I meant to do 2 to the 2nd power on top, 2 to the 5th power on bottom. My mistake. So here it's 2 squared, or 2 to the 2nd power, 2 to the 2 minus 5th power, I suppose is the most accurate way to say that. So 2 minus 5 is a negative number again. In this case, it's negative 3. Weird, again, that still feels uncomfortable. What do we do with that? Well, let's look at it from another perspective. 2 times 2 on top is, well, 2 times 2. And then 2 to the 5th power, 2 times 2 times 2 times 2 times 2. Well, if these cancel, turn into 1. These cancel, turn into 1. Well, what we end up with is 1 times 1 times 1 over, well, 2 times 2 times 2, isn't that just 2 cubed? 1 over 2 cubed. So what I'm noticing here, the pattern that I'm noticing, is that we got 2 seemingly different results, but what that tells us, what that tells us and something we can take away, is that if you have a negative power, that just means you have a positive power in your denominator. So 2 to the negative 3rd power is the same thing as 1 over 2 to the 3rd power. In the same way up here, x to the negative 1st power is the same thing as 1 over x to the 1st power. So if you have a negative exponent, no matter what it is, you can make it positive by just throwing it in your denominator. Or if you have a negative exponent in your denominator, you make it positive by throwing it in your numerator. So it just goes to the either from the bottom to the top or from the top to the bottom. So in general, this rule of negative exponents, so you can say if you have x to the negative a power, that's the same thing as 1 over x to the positive a power. Okay, 2 new tools for your tool belt. Anything to the 0th power has a value of 1, because we're leaning on that division rule of exponents. And then any negative exponent, x to the negative a in this case, is the same thing as saying 1 over x to the positive a power, where a is any number and x is also any number. Okay, power of 0, negative powers. Let's dive into some practice problems. You got this.